Hello, Code Labs! In the past 4 weeks, our team, Dylan Finn, Emily Yu, and myself, Zage Phillips, have worked hard to create an open source equivalent to Zoom, which we have named Castway.
Amidst the unprecedented pandemic, more people have been forced to work and socialize from home, which has made web conferencing applications more and more crucial, such as Zoom. Over the last few months, however, Zoom has been consistently criticized for the poor security and privacy. Thus, Castway was born.
To combat security and privacy concerns of Zoom, we thought, why not solve this issue by making our own Zoom clone? Hence, our plan was to create our own multi-peer video chat application with a client and server, which we will talk more in depth about later. Starting out, our goals for the project were 1. To successfully create an open source equivalent to Zoom. 2. Learn an industry tech stack. And 3. At the end of 4 weeks, deploy a functional and useful application to the public. Our tech stack consists of React, TypeScript, Yarn, Node.js, GitHub, and Visual Studio Code. In the beginning, learning the tech stack was a difficult task, as many of us were unfamiliar with React and TypeScript, resulting in hours of YouTube tutorials and reading online documentation. Once we felt confident with our skills, we moved on to determining our minimum viable product, or MVP, requirements. We decided that users would join a meeting room via a secret link, a URL only accessible to those who were given the link. Using this secret link would bypass the need for a login system, which would have required a database and more backend configuration. Furthermore, to successfully complete our MVP, we required that multiple people must be able to interact with each other in a meeting room.
With all this in mind, we moved on to building this basic functionality. We started out learning about signaling servers, an essential component to creating a connection between peers. The general idea of using a signaling server to create a handshake between clients is shown on the slide. Client A sends a signal to the server asking to connect to Client B. The server then sends the signal to Client B, who either rejects the signal or accepts the signal, sending out a return signal back to Client A through the server. However, once this round trip of signaling is completed, Client A and Client B can now communicate directly with each other without the assistance of the server, or in other words, have successfully created a handshake. After understanding the process of connecting peers, we began exploring WebRTC, which would allow us to add real-time communication capabilities to our application, such as sending video, voice, and generic data between peers. After doing some research, we learned that to get optimal results for multi-peer functionality, using the Simple Peer package was best. Simple Peer wrapped the browser's WebRTC implementation to provide a configurable and easy-to-use peer-to-peer connection. Then, with the help of the signaling server, we implemented a mesh network of peers, allowing every person's stream to be shared with all the other users in the room, thus successfully creating a remote media stream connection between peers. 3 main files were needed to establish the multi-peer connection: a server.ts file which contained the signaling server, a CreateRoom.ts file which created the secret link, and a Room.ts file which handled connecting user audio and video streams via the mesh network.
The server file holds our signaling server, which as you can see handles events such as sending and returning signals when creating peer connections.
The create room file is fairly simple. It creates a unique identifier for the secret room, which is then added to the browser link, making the identifier accessible for later use when placing peers in the same room.
The room file is where most of the app functionality occurs, and where later features are added. Peer instances are created and added to a specific room, and their media streams are connected through a round trip of signals.
After successfully creating a basic multi-peer connection, we moved on to adding other features, such as the ability to screen share, communicate through a chat log, and even mute oneself. Now we will have a quick demo. Notice the series of buttons next to your user video, and how when the mute button is pressed, it highlights itself to indicate that the user is muted. Now simply share this link with your friends and wait for them to join. Now we will demonstrate the ability to screen share. There are many capabilities one has when their peer or peers are screen sharing. You can pause their video if you choose to do so, you can full screen their video, and you can even pop out their video if you would like to continue viewing their screen while moving to a different tab. Now we will demonstrate our chat log. Our chat log not only allows peers to message one another, but also implements the use of emojis and Markdown. Implementing Markdown allows peers to not only bold and italicize messages, but also send links to one another. Lastly, note that at the bottom of the page we have a link to our GitHub repository, so users can feel free to check out our code anytime.
Now we'll move on to the project structure. We used a Node.js signal server to establish our peer-to-peer connections. Then, we used a React TypeScript client server to act as a front end and make each user an autonomous socket peer. We used Docker, Compose, and Nginx to deploy, which now also features HTTPS. The architecture of Castway is largely built around the open source WebRTC protocol to introduce clients to each other. The signaling server introduces the clients and coordinates the handshake, but once this is done, the clients connect to each other directly and the server is no longer needed. To the right, you can see an entity relationship diagram. Note that while this only shows 2 users, more can connect to our room.
Throughout these 4 weeks, we learned best coding and commenting practices, as well as how to collaborate with others using Git and GitHub.
Moving forward, we plan to continue improving this project, refining our code, and adding other useful features. For instance, a more scalable application would be ideal, which is one aspect that we want to work on in the future. Another aspect we would like to focus on is virality, and how we can spread our product to a wider audience. And finally, modernization. Since we want to continue working on this project, it will always be a constant goal to modernize our application to suit the needs of our users. These are our objectives in moving forward.
If you have any questions, comments, or concerns, feel free to contact us.
Thanks for watching!